over our radical and rational exponent exercise solutions. So let's write the following exponential expressions as a radical. So here we have x to the 2/3. So if you remember from the previous video, your numerator is your exponent and your denominator is your root. So we're going to stick this 3 inside the root, stick this 2 as an exponent, and we get the cube root of x squared. Now that can also be written as the cube root of x squared. So you can either take the root first and then the exponent, or you can take the exponent first and then the root. So let's look at 8 to the 2/3. So if we have 8 to the 2/3, this 2 is in the exponent, and this 3 is in the denominator, so that's really the cube root of 8 squared. So what you can do is you can take 8 squared first to get 64, and take the cube root of 64 to get 4. Or we can reverse that and say we can do the cube root first, so we can do the cube root of 8 first, and then square it. So the cube root of 8 is 2, and 2 squared is 4, and notice those answers are the same. Let's look at negative x to the 1/4. Now, exponents come before multiplication in the order of operations. When you take something and you make it negative, you're really multiplying by -1. So this is the same thing as -1 times x to the 1/4. So only the x is being raised to the 1/4 power, and then it's being multiplied by -1. So when I write this is going to be my exponent, this is going to be my root, and that's going to be the 4th root of x, and then this negative will just carry through and be multiplied in at the end. So that would be negative 4th root of x. Now if I had stuck that negative inside the parentheses, that's telling me, since parentheses come before exponents, that's telling me I want you to make the x negative first. I want you to multiply by the -1 first, and then raise it to the 1/4 power. And so if that's the case, then that's going to be the 4th root of negative x. See the difference, and I want you to pay very close to the difference between those two. So if we had -81 to the 1/4 power, since that negative is not in the parentheses, that's really just multiplying by -1, which means I'll do the exponent first. So I'm going to take the 4th root of 81 first and then distribute the negative to get -3. However, if I had that -81 in parentheses and I did -81 to the 1/4, then I'm saying, okay, make that 81 negative first and then take the 4th root of it. But if I do that and I try to take the 4th root of -81, I'm looking for the number who multiplied to itself 4 times gives you a negative. But we know a negative times a negative is always going to be a positive, so a negative to any even power is going to be positive. There's no real number, there's no number in the real number system that you can multiply to itself an even amount of times to get a negative. So the 4th root of -81 is non-real, because you cannot take the even root of a negative number in the real number system. So again, I want you to pay close attention to the difference between those two examples. All right, so if we wanted to write radicals as fraction exponents or as exponential expressions, take the square root. So remember, our exponent is our numerator and our root is our denominator. But notice there's no root in here and there's no exponent in here. But we know if there isn't an exponent, it's automatically a 1. And if there's no root, that number, that square root, is actually a 2. So the square root of x is actually the 2nd root of x to the 1, which becomes x to the 1/2. The 5th root of x to the 9th, again, the exponent is going to be your numerator, which is 9. The root is going to be your denominator, so this will be written as x to the 9/5. Notice for this one, the negative 6th root of x to the 5th, notice this negative is on the outside, so that's not part of the actual radical. So when I take this exponent as my numerator and that root as my denominator, here, in the 5/6, I leave that negative outside of parentheses because it's not included in the radical, so it's not included in the exponent. So let's simplify the expressions with no negative exponents. And we're going to write our answer in exponential form as well as radical form, if possible. All right, so here we have the square root of 25y to the 8th. Remember, taking a radical is the same thing as raising to a power. So taking the square root of all of this is the same as raising to the 1/2 power. And as we've discussed before, if you're raising to a power, as long as you don't have addition or subtraction inside, you can distribute the exponent. So the same rule is going to apply to a radical. As long as we don't have addition or subtraction in here, we can actually distribute this radical, and that can become the square root of 25 times the square root of y to the 8th. Well, the square root of 25 we know is 5, And here we can rewrite this as, remember there's an imaginary 2 here, y to the 8 over 2. And so that will reduce to y to the 4th. So the square root of 25y to the 8th is 5y to the 4th. The cube root of 27t to the 7th. So again, we don't have addition or subtraction. I can distribute that exponent or that radical and take the cube root of 27 and the cube root of t to the 7th. So here the cube root of 27 is 3. So here in radical form will be 3 times the cube root of 7t to the 7th. To write that in fraction exponent form, that will be 3t to the 7 over 3. All right, here, w to the 2/3 times w to the 5/7. Like bases being multiplied, we will add their exponents. So we'll take and add those two fractions. So we have to think back to our fraction arithmetic. In order to add or subtract fractions, you do have to have a common denominator. The easiest way to find a common denominator is take the opposite denominator. So here I'll take this 3 and multiply the top and the bottom here by that. Here I'll take this 7 and multiply the top and the bottom here by that. And that'll give me w to the 2 times 7 over 3 times 7 plus 5 to the times 3 over 7 times 3. So when I multiply those out, I have 14 over 21 plus 15 over 21. Notice now I have a common denominator. Once the denominator is the same, you can multiply, or you can add or subtract their numerators over that denominator to get 29 over 21. So there we are in exponential form. To put it back in radical form, this is going to be our root, this is going to be our exponent, so it'll be the 21st root of w to the 29th. Let's do another example. X to the 9/4 over the square root of x to the 5th. In order to simplify with exponents, you're going to have everything in exponent form. So we're going to have to take that square root of x to the 5th and turn it into a fraction exponent. And so now I can see that I have like bases being divided. I will subtract their exponents. So that will become x to the 9 over 4 minus 5 over 2. I will need a common denominator. If you don't know how to do it, again, you can multiply the top and the bottom here by 2, and then top and the bottom here by 4. Just remember, anytime you do fraction arithmetic, at the end you will have to reduce your fractions. Or some of you may see, hey, if I just multiply the top and the bottom here by 2, I would have a common denominator of 4. And so I have 9/4 minus 10/4, which gives me x to the negative 1/4. Now, as we've discussed before, you can't take a value and multiply it to itself a negative amount of times. So I can't take x and multiply it to itself negative 1/4 times. So before I can even think about translating this back into radical form, I have to get rid of that negative exponent. In order to get rid of a negative exponent, you move it to the other side of the fraction bar. This is really over 1, so I'll just bring it down to the denominator to make it positive. And now I can put it in radical form by calling that the 4th root of x. That's it for now. See you next time.